Hello students, welcome back to OrganiChemVerse. Let's find out what is product A for the given reactions. The given molecule is having two ketone functional groups and it is treated with sodium hypochlorite followed by the hydrolysis. So this is sodium hypochlorite. So many students fail to understand what this reagent does, but they do know what happens when we take a methyl ketone molecule with chlorine in NaOH, right? It's nothing but a reaction which will form a chloroform as a byproduct. So let's see, when chlorine reacts with sodium hydroxide, it's going to form sodium hypochlorite and the byproducts are NaCl and water. What is our main reacting species here? It is sodium hypochlorite. So when sodium hypochlorite reacts with methyl ketones, so where do we have the methyl ketone? Here. Look at this, COCH3. And this is the methyl as it is. So when it reacts, it's going to break the bond over here, right? Because this is going to form the chloroform. This is what I meant earlier. Then what happens to this? It's going to form the carboxylic acid. That means what? This is an oxidizing agent. So it's oxidizing the methyl ketone to the carboxylic acid. So this ketone will not react. Why so? Because it's not a methyl ketone, right? So then what about this? This is going to form the salt of the acid. So what salt? Since there is a sodium, it's going to form the sodium salt of the acid. This methyl will be as it is. Students, remember here, if you use the sodium hypochlorite, you are going to get chloroform as a byproduct. If you use bromine, bromoform. If you use iodine, it's going to form the iodoform. So if you are using the NaOI, right, sodium hypoiodide, in that case, what happens? It will form yellow precipitate. So that is nothing but test to check the presence of the methyl ketones, right? This is just additional information. Now, since you are hydrolyzing this, right? So you are doing neutralization. Then what happens? It's going to form the acid like this. So generally these are heating conditions, okay? It is understood. Then what happens? It will undergo decarboxylation. So what is the driving force here for the decarboxylation? Because look at this. This is alpha, this is beta. So beta keto carboxylic acids easily undergo decarboxylation as the formed carbanion will be stabilized by the resonance like this. What about this methyl? It will be as it is. So then what happens once it undergo tautomerization, since there is an acidic medium, right? So then what happens? Here you are going to get CH3 and the hydrogen will be here. So this is nothing but, so you can give the name for this. This is 2-methyl cyclohexanone. Check where do we have 2-methyl. So this is 2-methyl cyclohexanone, right? So the right option is option C. Thank you for watching this video. Until next time. And if you have not subscribed for the channel, please do subscribe.